Hey guys, I'm going to give you a quick lesson on average rate of change, otherwise known as Aroc. And really, before we get going, I just want you to know that all we're talking about here is slope. We're just talking about the slope of a line. And so this entire lesson, if you'll just think of it as a big lesson on slope, then you'll won't have any problems at all. So before calculus, we've always found slopes of lines. So one thing you need to know about a slope of a line is that, and I'll just refer to it as rate of change, but rate of change when we're talking about a linear is always constant. Okay, so right here, if you look at this linear, this is known as a positive slope. This one here is known as a negative slope. Here we have a vertical line. That slope is undefined. And then here, this linear is horizontal, so it has a slope of 0. Okay. And then once you know calculus, so after calculus, we start to talk about slopes of curves. So if you look at my picture over here on the right side, you'll see that the slope of a curve is always changing. So right here, we have an increasing slope. Okay, positive slope. Then it turns constant right in here. Then it turns negative. Goes back to constant right there. And then it goes back to positive slope there. So throughout the entire curve, that slope is always changing. So there's a couple different ways that you can find the slopes of curves. And we're actually going to use a couple of different lines. The first one I want to talk about is a secant line. So this is testing your geometry knowledge a little bit. So it's taking you back a couple of years. But a slope of a secant line now that is a line that touches a curve. So they probably taught it to you with circles like this. And it touches a curve at 2 points. That would be a secant line. So if you're going to use a secant line going through this point and this point on a curve, then that is known as the average rate of change. And we'll say the average rate of change on a specific interval, on an interval. Because that average rate of change, or Aroc, is going to change depending on the interval. So for example, let me grab a ruler real quick. If I want to know the average rate of change from, we'll call this from A to B, then I would use a secant line right there, and I would find the slope of that secant going through those two values on the curve. Okay, so here at x equals a, this is going to give us f of a, and this at x equals b, that's going to give us f of b. You can see that it's not exact, Okay, we're not finding the exact slope of that curve, but it's pretty close. We can run a secant line through these two values using just the regular slope formula. It looks a little different, but it's just y minus y over x minus x. And we'll say on this specific interval, on the interval AB. Okay? So again, a secant line gives you the average rate of change. We can find the slope of that line using the slope formula, okay, also known as the Aroc formula. The slope formula on a specific interval. So let's look at this example real quick. Example 1. Find the average rate of change of the function where f of x equals the square root of x plus 1 with a plus 1 on the outside on the interval 3 to 8. So our formula is f of b. So we'll say f of 8 minus f of 3 over b minus a, so we'll say 8 minus 3. How do we find f of 8? We just plug it in. So here we plug in an 8 there, we get the square root of 9, which is 3. So 3 plus 1 is 4. Plug the 3 in, we get a square root of 4, which is 2. And then 2 plus 1 is 3. And that's still over 8 minus 3. So we end up with a 1 over 5. Now the way we write this answer is really important. When you get to your AP testing and all of that, you'll actually get graded on how you present this answer. So there's a couple of important things. One is what the actual rate is. So the rate is 1/5, but it's a positive 1/5. So that tells us that it's increasing at that rate. And then you also need to state the interval. And remember that our interval here is 3 to 8. Okay? So for this particular answer, we would say Aroc is increasing. Again, remember that that just means that your slope there is positive. It's a positive 1/5. So Aroc is increasing at a rate of, probably should say average rate, because we are talking about an average rate. At an average rate of 1/5 on the interval 3 to 8. So you just write it in a complete sentence like that. The only thing we're missing there is units. So if we were talking real world stuff, we would make sure to add some units in there. Like the example down here. Find the average rate of change of the population on the interval 1995 to 1998. So we would say f of 1998 minus f of 1995 over 1998 to 1995, or minus 1995. So f of 1998, if you just look at the table, is 13,000. F of 1995 is 10,000. And that's over 3. So we get 3,000 over 3. which is 1,000. So what are we talking about here? We're talking about 1,000 people per 1 year. Y over X. So it's people per year. Okay, so let's write that out. Let's write a good sentence talking about the average rate of change. So we would say average rate of change, Aroc, is increasing because it's positive. So that's one of our keywords that we need. Increasing at a rate of 1,000 people per year from 1995, so there's your interval, to 1998. And I didn't put average rate in there, but really this says average rate right here, Aroc. That's what that means, average rate of change. So Aroc is increasing at a rate of 1,000 people per year from 1995 to 1998. That's how you would want to write that answer. Okay, so again, we're just talking average rate of change, which is the slope of a secant line. Depending whatever your interval is, let's go back to this picture, whatever your interval is, so our example is just from A to B, so you would run a secant line on the curve going from A to B, and then you would find the slope of that secant line. Now this part over here, this is what I'll actually work with you tomorrow on this. I can show you a good way to find the slope of a tangent line. Normally we would use calculus for this, but I can show you a good way that will help, and I'll go over it in class tomorrow. But remember, a tangent line just touches the curve at one point. So the slope of a tangent, let me drop that down, I'm sorry. There's a tangent line, touches the curve at one point. So the slope of a tangent is known as an instantaneous rate of change. So this is at a specific time, so we'll just call this A. What is the slope of the curve at x equals A? Well, we need the tangent line because it's only going to touch it at A right there. So we would have to find the slope of that line. Okay. And again, like I said, I'll talk about that a little bit tomorrow. This example one, I intended to give you a picture for this, so if you want to draw a little picture over here, you can see what's going on. But you're talking about a square root that moves left 1 and up 1. So it'll go through right there at 2. So there's our curve. And we're going to find the average rate from 3 to 8. So there's 3, there's 8. So what we're finding is the slope of this secant right here. Very close to the slope of that actual curve from 3 to 8. It's just a little off. So that's what we did right here. So that's the slope of that secant is 1/5. So that's an average rate. So the slope of that curve is really close to 1/5. Okay. And again, we would need calculus to get an exact slope of that curve at any of those points between 3 to 8. But I can show you a method tomorrow in class that'll get us really close, even closer than 1/5. But anyways, that's average rate of change. If you turn this over, you'll see your homework on the back. You're given specific functions here, 63 through 70, and you're given an interval on the right side from x1 to x2. So go ahead and write those in complete sentences. Make sure you state whether it's increasing or decreasing and on the specific interval. Okay, thanks. Have a good day, and I will see you tomorrow. Bye-bye.